and no chicken. I have too many windows open, people. What's going on? What's going on? Could I program a cure for corona by any chance? I mean, I could try. I don't think it would work very well. Yeah, the PS5 is super good with extra good sauce. It is true. It is true. So we're getting close to the release of the next beta release, but I want to fix a few more bugs before that happens. And then maybe we'll let's documenting some stuff in the morning, and then maybe we'll ship it. Glad you enjoyed the game. What are the bugs today? Well, I don't remember what all of them are. One of them is this. One of them is that for some reason, having a constant array as a default parameter value is not accepted. And if that's easy to fix, I would like to fix it. If it's hard to fix for some reason, maybe we'll put it off, but I think it should be easy. Yeah, non-imperative declarations can only be initialized as constant values. Well, bro, okay. Like, why does it think that's not a constant? I can imagine some reasons. Oops. So, I mean, the thing is, there's more stuff about PS5 that's really good that hasn't been announced. So, I mean, that demo is definitely one thing. The amount of data throughput, it's major, but there's other major things. It's going to be a really good console. Yeah, it's bananas. Some of the other stuff's bananas too. I'm just saying. I am just saying it is bananas. Okay, so is this the right? Yeah, okay, so let's go again. Why? Oh, it's a it's casting. Fudge. So the deal is, when I do this, it's casting this to one of these, which is causing this to not be a constant. Anymore for the purposes of this call, because it's seeing the thing after the cast. I could allow this in this special case. Will I be able to talk about the stuff after the console launches? Probably. I don't know. Like, I don't really keep up with. Does the int tell it what type the element of the array is? Yes. Can it be omitted if it can be inferred from the variable declaration? Not right now, although we may do that later. Right now, type inference basically just goes in one direction always, which is what makes it fast. Well, that's a little bit of an oversimplification, but yeah. Are generics inferable? What does that mean? You will have to get more specific about that question before I can answer that. okay. So I mean, instead of passing this down to the bottom, I could check for it up above. And the thing is, I mean, basically any implicit cast, we should be able to remove. All right. So another thing, this is line 1031. Everybody remember that? Oh, 10.131, not 1031. 10.131. Like if you have x int equals f of y, where f is x $t, does it infer $t is int? It infers $t is whatever the type of y is, which you haven't said. Unless you're saying it's supposed to match the return type to x, but you didn't say there was a return type in that function. And no, we don't match return types. For the same reason I already said. Where things go in one direction. Let's say you're calling a function that returns a collection of ints. You declare a variable to store that function's results. Do you need to type that variable? Well, if the function is generic and the variable is auto, then there's no way to know what the type should be. Oh, wait. No, you're saying a collection, an array, you mean, an array of ints. What does that have to do with generics? Now I don't understand the question because there's no generics in the question. If you're calling a function that returns an array of integers, you declare a variable to store that function's results, do you need to type that variable? I mean, the variable is of a type. You don't need to declare the type because it's inferred, but I mean, you said it was an array of ints, but then you're asking, do you need to give an explicit type to the array? And the answer is, you said it was an array of ints, so I don't get it. I feel like he's talking about collections from other languages where a collection is an interface. Well, in this language, types are all known at compile time. If the compiler knows what they are, then you don't have to put them in. Otherwise, you do. Okay, so at 10.131, we're going to check to see if it's an implicit cast in an argument list or a return. Okay, so I think the other case in which this won't work is any, right? So that also will be a cast. So I think if I try to compile this program, yeah. So we want to make both of these work. And then, yeah, okay. So if we have an any or an array view in an argument or return declaration, normally we wouldn't see this as a constant because during type checking it will have had an implicit cast grafted onto the front. So here we strip implicit casts before asking whether something is a constant. That's okay because they will be added back during procedure calling when the argument is provided. Okay. So we're going to say query input equals this. And then we're going to say if query input is not a cast, break, cast is static, cast as cast, query input. If not, is it cast flags, cast is implicit. Let's just do this. Okay, we have to check block type. If it's arguments or struct arguments or returns, then we do this thing. Otherwise, we leave it what it was. We say, ba-bum, ba-bum, bum. Let's put this, whoops. Let's put this down here, where it'll be more explanatory. Is it called sub-expression? No. It is called expression. That was my first guess, and I was like, I probably changed that, but nope, I didn't. All right. Default values must be constant. That is a different check. And it's redundant, I think. Yeah, this one, oh, is this one we're actually calling? No. Okay. I don't feel like we should be doing this anymore. Let me see if I could delete this. I mean, we still need this other part, but we could, like, wait, like that? Yeah. Let's see what happens if I comment that out. We'll see how bad it is. That's fine. What are we working on today? We're just bug fixing from some things that people reported. This one is not exactly a bug. It's just like a feature that doesn't completely work with everything the way it should. Why isn't a string literal constant? It is constant. It's just that during the type checking, it gets casted to any in order to match on the left, right? So it's the implicit cast that is not constant. Okay, and that's the whole thing that we're doing right now, is we're skipping the implicit cast. Yeah, I don't think this code that I just commented out actually needs to be there, but let's run some tests with it. Would facilities like dead code analysis end up in the compiler or in libraries? We will probably do dead code analysis by default because we would almost get it for free. Like again, if you don't imagine this whole thing where you have a linker is just a really weird situation, right? Imagine you don't have a linker. Then when you're compiling your program, you know a procedure gets called or is used if it's ever called directly by another procedure or assigned to a variable, right? If one of those two things doesn't happen, there's no way for anybody ever to use it, right? And so in the course of compiling the procedure, you just naturally know which things are used, and then you don't even have to compile the things that are unused. And that is why we might put it in, because, you know, if you import a module or something and you only use 25% of the functions, you probably shouldn't have to pay for compiling the rest of it. You have to parse the rest of it no matter what, but parsing is very fast. So that is a thing that we might do. Anyone who says tree shaking is fired. Okay. Let's just delete this. I'm happy to delete that. Did we still have that in the to-do? No. Okay. Great. So, Like this code doesn't actually do any real work. It was just a redundant check with this other thing that was already happening, as far as I know. So let's see now. Well, we didn't like that. I don't understand why we are even doing this. Why are we doing this eval? I think we just do this. Undeclared identifier for expansion. Oh, on any. Haha. Because we're doing a for loop. That means our thing worked, though. Because I kept calling the variable array. There we go. Array is hello. Hello. And then if I do this one, then our for loop boom. So that works. Okay. So you guess the heuristic is along the lines of this isn't obviously a good thing for most cases, so we'll include it with the compiler. Yeah, I mean, if there's something that most people want turned on, we will just put it in the compiler, right? Because it's faster that way. If it's something that a lot of people might have different opinions about, that's a good user library thing. Okay. Okay. Where do I put this? Any array literals, any types. So now work in procedure, argument and return declarations involving default values. let's just test a couple more things, and then we'll file this away as a test case. Okay, so just going to do both of those again. Let's go to, yeah, we did release compiler. Whoops. It's not called .data. It's called, what is it called? Data pointer? What did I call it? Value pointer. All right. There we go. So both of those work. Now, test 3. Returns colon equals going to put some new lines in here. Whoops. It was missing its body, but let's put something in there just to, all right. Not all control paths. There we go. So we successfully returned this as a default return value. That's pretty good. Let's make a test out of that. Okay, so it really wants to be called data, maybe. That is possible. Okay. Why is this all messed up all of a sudden? Okay. Okay. Great. So this one might be, oh no, this one's new. Oh, we don't even need to. So remove the using or make the function non-polymorphic to get rid of the crash. Well, yeah. I can sort of see why this is happening. Hopefully it will not be that hard to fix. This is a thing that it's like a remnant of some stuff about the way the compiler is currently done that'll probably go away eventually. Hopefully. All right. We're polymorphing. Oh, this is a little different than what I thought. We're actually polymorphing the function. We're copying the struct. Okay. So basically, this probably gets set in the parser usually. Well, no. Because it doesn't happen for procedures. Basically, we just don't really copy structs very much. All right. We're just going to look at what's on the stack when we do this. I mean, the thing that you guys have to understand about this demo today is it'll be a while before you see anything like that in actual games. And in fact, the smart money. So historically, because demos are demos and not full games, historically, when someone releases a cool demo, that really shows you what games will be like in 6 years, right? Because that's the job of a demo. And so, well, I mean, and in this case, maybe even a little bit more, because the thing is, Unreal Engine 5, they said, is not even available till next year, right? We'll see. But, you know, I mean, demos are demos and they're different from games, even if they look a lot like games. So it's real technology that exists. It's just you're seeing it a little bit more in the future than maybe people think. Probably no shipped games with that until late 21, 22. No, probably later than that. I mean, I doubt you see anything ship I mean, you can always trivially apply this stuff by like not putting that many meshes in and whatever, but you're not going to see this in 2021 is what I'm saying. You're probably not going to see it in 2022. It's going to be a little bit. Is that a limitation getting the tech out the door and market diffusion not justifying the work for 6 years? It's a lot of things, right? So first of all, games take a long time to make, right? And so you have to have this technology available at the start of the game development cycle in order to use it. B, demos are just way, way easier than games to make because a demo doesn't have to do many of the things that a game has to do. Right? Now, this demo was probably better than a lot of demos in that it involved moving through space and, you know, it was doing physics and playing sounds and all that stuff. So that's more real than demos usually are. But when you actually have a game, there's all kinds of things that make it more complicated every time. So, you know, like with the demo, because the point is to be a demo of this thing, every decision in the demo is bent around showcasing the thing they want to showcase, right? And with a game, it's the other way around. It's like you want to use the technology that that demo is showcasing to do the things that you want your game to do, right? And so you're going from like a territory where everything was bent around the thing to trying to bend that thing around your thing. It's not very easy, and it takes a long time and it's hard. I feel like that was a demo for the movie industry, quite possibly. What do I think of UE5? Any aspects I find? I haven't seen UE5. I've just seen that demo. Like, yeah, it was a cool demo. I want to know. I want to know how large of a volume their real-time lighting can do and what the constraints are. And yeah, I don't know. But the engine itself, assuming it's like prior Unreal engines, I won't like it that much structurally. I think working with the Unreal engine is like doing your taxes every day for the rest of your life, you know. But, you know. I'll be really interesting to see what Unity's attempted response is to this, because it was a really good demo. And Unity, from what I can tell, is having a hard time just even running with all the bugs. Like, they need people who do streams like I'm doing here, fixing bugs on Unity, like real bad. They need like an army of people doing that. Something I mentioned a while back that I haven't gone, whoa, I didn't realize computers could do that in a while. You noticed that cross your mind as you were watching it. Yeah, this demo was a little bit like that. However, I was also thinking, I was like, wow, that's really impressive polygon counts. But I was also thinking, I don't really care. Like, they didn't do anything that you can't do with fewer polygons, right? It's just, you see more visual detail in an environment that has that much more visual detail, right? And so, that's fine, but it mostly doesn't help me do any game that I couldn't do before. You know what I mean? It's like looks higher resolution, which is good. It's good to have that capability, but it's like, I don't know what it really, I mean, the real-time lighting actually, if it works really well and is very frictionless, that probably has a bigger impact on your ability to make certain types of games than the geometry does. Yeah, baking light maps is a pain in the butt. If you really can get rid of that, that'll be good. Question though is like, okay, how much? So, you know, baking light maps is a compile time equivalent operation, right? And doing lighting dynamically in a game is a runtime operation. And so you're paying for it at runtime. And the question is just how much are you paying for it at runtime? Now you are getting extra things. It's like, it's not just that you're paying not to have to bake the thing. You also get more responsiveness. You can move the light around. You can do all sorts of fun, cool stuff with it that you can't do with pre-bake. So it is more capability, but you are paying for it, right? And the question is how much? I don't know yet, right? You pay for nothing if the light doesn't move. No, see, I don't believe that. That's never how it works. You always pay. You always pay. Okay, so we're asserting that we have an enclosing scope on this, and we don't because we copied it from a struct here. And that does not set enclosing scope on using for some reason. Because, well, we have a different thing. We have this thing that we use to copy blocks. Okay, but we do eventually call that actually. Right. So this do members is for like arguments and returns. That's kind of weird, but that shouldn't be in play here. So we should have been here. We're just going to step through this because this set enclosing scope right before the add statement should have done that. All right. So we're going to do that. Oh, wait, we're not calling copy of block, right? All right. Let's just, I'm going to make a note there that I think we should be calling this other thing, but I'm just going to fix this. I'm going to spot fix this for now because my long-term plan is that copier goes away, hopefully. So okay. Yeah. So, okay. So, whoops. We just kind of did this here. So that might not be the only problem that we have here, but I guess it was. All right, let's put that. Polymorphic procedure containing a struct. Yeah. All right. Easy enough. Easy enough. Okay. Bam. Just making sure the game runs. Making sure the game runs. Okay, this one. I don't know if I fix this. I feel like I did, but let's see. Oh, I did. And whoops, our test succeeded. Fix a copier crash. Bam. Okay. So this one, I don't remember what this was about. Wait, we already did this one. This was half of one that involved another. It was about an error message being good. We did that on stream. So I think that's all our actual crashes that we know about right now. Although I made a new stress test that can turn up more crashes at some point. Uh-oh. Well, the build machine still doesn't like things sometimes, but, you know, we're working on those things. What do we use for continuous integration? We have a loop that runs our program and emails us. It's not a shell script, it's a program. I don't remember what, I think we use, let me see. We just use this mail module and Avner put it together. And, well, uses curl, I guess. Watching the PS5 demo makes you feel even more stupid for still doing web work in React.js. I mean, the difference between what web programmers do and what game engine programmers do is very, very, very large. It's very large. If you don't need it, don't use it. Like, it does. I mean, I a little bit disagree with the philosophy that you should need a giant thing to run your program and email you if there's a problem. Like computers are supposed to be simple, you know? Do I buy a lot of courses or read a lot of books, documentation to keep my skills up to date? I certainly don't buy a lot of courses. No. I do try to read things to expand my knowledge when I can. Those will tend to be random things that I find around that I'm interested in. But honestly, I don't do as much of that as I think I should, just because I'm busy a lot of the time just programming and doing whatever. Do I think it is a good idea to call a function through a function pointer by choosing the correct implementation at runtime? I mean, sure, except like I almost never have to do that, right? So I have to ask you, why do you think you have to need to choose the correct implementation of something? Are you trying to be too complicated, or is there actually a good reason to do that? Because you know what? If it's otherwise an if statement, branch prediction is real fast. So why are you doing that? It depends if you have a good reason. Computers are definitely not simple currently, and they probably will never be as simple as we wish. But we need to make them as simple as possible, or else, bad things. Simple is much better than complicated, yes. Yes. Like choosing AVX versus SSE based on CPU. I mean, again, branch prediction is really fast, right? I'm not exactly sure what the penalty is for calling through a function pointer in terms of branch prediction. I know there was a time at which that was actually really bad, like it would flush your entire pipeline. I don't know if that's true anymore. I doubt it because of how much C++ has vtables and stuff. I would say that you should investigate what the performance penalty is of doing that and see whether it's better to do that or have an if statement. I mean, okay, so here's the other thing, right? If you're doing AVX or SSE or something, that stuff is fast when you do a large computation with it, right? I mean, not necessarily large in terms of milliseconds, but like large in terms of, it's not a couple of instructions, right? It's like a block of stuff, because getting things into and out of SSE or AVX is a little slow, right? So the question there is, how much work are you managing to do while you go into AVX or whatever? And then is the overhead of a 100% predicted branch around that worth getting rid of? Keep in mind, it's 100% predictable because you will never take the other branch. Is the overhead of calling a function not usually larger than a correctly predicted if statement? Correctly predicted if statement. It is. I would say probably. I mean, it depends on some things, right? Like as far as I know, branch prediction data is still stored in the instruction cache, right? So if code is rarely run, I mean, you know, like maybe you run it once a frame or something, and it's not going to be in the instruction cache the first time you hit it. Except, of course, the instruction cache is prefetched, so like whatever, but, you know, this is well out of my domain of expertise. I just have vague ideas about this stuff, but, you know, usually I think that branch is going to be very, very fast, right? Unless you hit a weird pathological case like I was just describing. And calling a function, yeah, that involves, I mean, it's many instructions, right? But you would be calling a function anyway, right? Like if you're going to do some big batch of math, you're calling the function that says, do this math in AVX or SSE, right? Versus calling through a function pointer. So it's not like you can say that it's an extra function call, I don't think. As long as the pointer is consistent, it's not a big deal. Yeah, probably, because again, you know, C++ has vtables all over the place, and people tend to optimize for code that people have. But if I'm just guessing, I would guess that the branch is faster. It may not be faster enough to matter for your particular application, but I would guess that the branch is faster. If it's predicted correctly, it's the same speed. Maybe. Yeah. I can believe that. I mean, at this point, you know, we start talking about architectural details that have changed over time and like, you know, which CPUs are you considering deploying your code on and all that. Like, once you start talking about, oh, the domain that we're discussing is all CPUs that people might be using today, then it becomes very hard to make statements, right? So you kind of have to pick something and say, I'm concerned with this area, and then you can start answering these questions, right? Okay. If you store your architecture type in the cache at the start of the program, don't expect to be through all the program execution. At some point, there will be a cache miss. But that's the same as if you stored a function pointer. It's exactly the same. Like, you've got a pointer-sized piece of memory that has to be in cache, or else you take a cache miss. It's the same thing. And again, if this is SSE or AVX code, it's probably hot most of the time, or else you picked the wrong code to AVX. But again, these are general statements, and you know, you really want to look at the specific case. Yeah, there's no way to, like, you can wish that you controlled the cache, but on a PC like this, keep in mind the operating system can swap in a totally different process onto your CPU at any time, right? So yeah, you can't like the programming model on like a PC is that you don't really get to own computing resources. The operating system owns the computing resources. So your program does not have authority to do a lot of things. Why isn't it possible to force memory into the cache? I mean, imagine that a program could do that and someone just DDoSes your CPU by locking all memory in the cache, right? Or more likely, there's just a bug and that happens. And then your computer, it's just, and the CPU needs to be able to guarantee that it has empty cache slots to do various operations. So, for example, well, okay, for for multi-core data consistency, right? Very often, what happens is, a CPU has to say, "Oh, my entire cache is invalid. Let me just wipe it and start over," right? If you think that you can lock data into the cache, suddenly that can't happen, and that's very bad. But again, this is not totally my area of expertise, so. Yeah, like what happens if you think you have a cache line locked into your local cache and then somebody else atomically increments that memory location on another core, right? What is your program supposed to do about that? It just doesn't, it's not how it works. There needs to be virtual cache. I know. How about if we swap the cache out to disk? That way, you always know that you have enough cache to store your registers. PS3 basically had a manual cache for the cells. I never used that stuff. Well, unless by manual you mean whatever you DMA there. Like, yeah, I mean, if you mean the actual memory that each SPU could access, then yes. But that was dope. That was a good architecture for what it was. It had some problems. I know what you could do. Okay. So first you swap the cache out to disk, right? And then you run disk doubler on your disk, and you'll get at least twice as much disk space because your cache is now compressed on the disk. Soft RAM. I remember when you would like pick up computer enthusiast magazines and they were all full of ads for this stuff like disk doubler, soft RAM, and whatever. Okay. Okay. I have emails from people. So damn, this file is huge. So someone was complaining that these aren't in here, but I'm like, maybe we need to use the reentrant ones. Let me just check those in, and I'll whip out the laptop and see if they actually compile. New lines. Let's see if these actually work. We're going to publish the source code for the compiler eventually, but not for a while. So now I'm on the laptop making the Linux builds. And there's something else that just Clang doesn't like. This, okay, maybe somebody knows what I should do here. So I added this a while back. Clang does not like this. It says that we cannot convert this. Maybe if that's not the first member. Let me see. Yeah, that's so goofy. All right. However, it's going to use that to size the thing. Okay, hold on. Maybe I should do that. Too many initializers. Okay. So if I do this in Clang, does that mean set it to 0? Because it won't take the version with 0. I don't actually know what this means. Okay, good. So we're just going to try this. I honestly should have tested that before checking it in. So we're going to do that while I'm over here. Going to update. Compile. Wow, it really doesn't like something I did. Oh, it did again. What else doesn't it like? Warning, multi-line comments. Really? It doesn't, oh, it doesn't like this. All right. Okay. Oops. That's a really old assert that is no longer necessary, that it's complaining about. Okay, it doesn't like these. So does anyone know about these get PWInt functions? Do I need to read about these? I mean, all right, we'll just use the non. Okay. Am I doing password stuff? Yeah, somebody just wanted that function to be available. So there we go. It shall be available. Well, that might be everything that I really wanted to do before shipping the next beta, apart from documenting things. And I might be too tired tonight to be in fresh brain documenting mode, so maybe that happens tomorrow. I think we document some stuff and then ship it. Beta 17. Password struct varies by platform. Yeah, but we define different things in there. So like this is probably the Mac. Wait, that's the Linux version. Here's the OS X version, etc. This is kind of garbage, though. I mean, it's 200 lines. It's duplicated twice. Well, not all of it though, right? Because some of it's different. Uh-oh, and different values. All right, well, maybe it's not a good idea to try to deduplicate that. What a pain in the butt. Are there many people on the Discord? I don't know the count of how many people there are there. Any plans for alternative to e.g. HLSL? Well, the problem is you don't exactly have a choice because these APIs, some of these graphics APIs dictate what the shading language is, right? And so if you want to use something else, you have to like cross compile it. And of course we can use compile time execution to do that. But like when your OpenGL driver wants a shader, it's only going to take one kind of a thing. You know what I mean? They don't have like a bytecode you can emit. Not really in the, I mean, the answer to this varies from API to API, right? For GL, I don't think so, but I think there is a way to ask for a binary blob of the compiled shader, but you don't know the representation of that, I think. That might be wrong. It's okay, web GPU has defined yet another shading language. I know, isn't it great? Isn't it great? At some point, I kind of don't know why this is all in one file. If it's just a giant if Linux and then a giant macOS. Like if it's enough lines, we should just load some files. I don't know, man. WebGL2 compute. Oh man. I just can't. I just can't do it. Well, this may be all the programming that I do today. We're out of things. I definitely have other things to work on. I mean, I could run some stress testing some more till we hit a bug, which we are likely to eventually. Whoops. There we go. We already hit one. I beefed up randomize. It used to not really reveal any new bugs, but now it's pretty good. It's pretty good at hammering on the compiler. So these are things that I need to fix. It's just I kind of want to do them. They're probably all the same, like one bug, even though it's asserting in different places. I kind of want to do it in the morning. So what I did today and a little bit a couple days ago was fix a lot of the problems that Randomize was showing in Sokoban. So like there were like 2 or 3 of them, and I fixed them, and there's probably still some seeds for which this might fail, but I've at least got the most of them, but I haven't done that process for the tests yet. And apparently they're exercising some things. Yeah. What did I add to randomize? It was actually very simple. So, and I feel, this is one of those things where I just feel stupid now that I didn't think of this a long time ago, because I could have hunted down all these bugs a long time ago. The original randomize was a thing I did way back when I was still first figuring out how the compiler would work. And it was like, oh, there's all these stages that things flow through and stuff. And things wait in a particular pipeline for a while till they're ready to be processed. So, you know, if every time I go to run that pipe, if I shuffle the elements in the pipe, then that'll be a good stress test, right? And I did that, and it did help find some bugs back when I first did it. But as the compiler architecture evolved and whatnot, it just seemed less and less effective at finding problems. And I never really thought about why. I was just like, well, I mean, I guess randomize doesn't really do anything anymore. I don't know why. And the reason why is just that, you know, when I go and try to empty out each pipe to see if things are ready to be processed, I iterate until completion on each pipe, because that's kind of what you want to do. You don't want extreme order dependencies where you'll process stuff slower if they happen to be swapped in order or something, right? So it's like, oh, well, and you know, after running that pipe, we go and run later pipes, and the things in this pipe are the food for the later pipes, right? So you want to make sure you get everything out of the pipe that you can. What that means, the fact that I was iterating completion means that shuffling the order of stuff within a pipe didn't really matter that much. Like it has a small effect on what the compiler does, but regardless of what order they were shuffled in, you were going to clear the same set of people out of that pipe on that cycle as you would have without randomize. And that is why, as I got a clearer picture of how things worked, it just didn't really generate any new problems because it wasn't really exercising anything serious. So all I did was I changed the concept a little bit. I was like, okay, instead, when something gets added to a pipe, we're going to roll a random number for it, and that random number is how many cycles it has to wait before it's allowed to be processed out of that pipe, right? And so what that does, that's way better than shuffling, because what that does is it just means different sets of guys are going to clear in different orders for any particular seed, right? And that exercises the kind of problems that we have in the compiler because, I don't know, like let's say you're compiling a procedure and the body and the header are parsed in a certain order like they are, right? And then you dump them in and they usually just happen to go through in the same order or in the same timing because they're probably referencing a lot of the same things. They don't really get hung up on anything. But if you intentionally hold one up and the other one goes way later in the pipe and you don't handle the fact, like there could be bugs happening because, you know, you didn't realize that the header might not be past a certain point yet. And it always happened to be before, right? And so that's what the new randomize is catching. And we've got most of the problems out of Sokoban. I mean, I don't know. If I run this enough, we'll hit one, probably. Eventually, so right now it just picks a random number, but eventually when things are hardened enough, we should just be able to iterate over all seeds, right? Like we could have a test server, and we can increment the number of seeds, right? Like right now it's only 1,000 different seeds because why bother with more if we're finding problems with it? But, you know, you could have 1 million different seeds or something, and then you can just run all of them and make sure they all work, right? Is execution order deterministic given the same seed? Kind of. If it's a single workspace compile, then yes. The weird thing is different workspaces, which is how you compile different things at the same time, those are threaded with respect to each other. And there's no way to turn off that threading right now. If I try to think about it really hard, I might be able to come up with a way, but that might complicate the compiler in a way I wouldn't like. Although last time I gave up on that, the compiler was a lot more complicated than it is today. So, yeah. It might be okay, like if I think about it again. But other than that, yes, execution order is deterministic unless, right, you can always have program bugs that make that not be true. So for example, if I'm doing something that's accidentally using an uninitialized value to make decisions, then that might be different between runs, even though we wouldn't like it to be. But of course, that's then a bug that needs to be fixed in the compiler. Today was one of those days that went by really fast. We could, let's at least start looking at this. Again, because it's late and I'm a little tired. I don't like, really? That's probably a different one than these other ones. All right. Let's look at this one, because this one's been bugging me for a while. Yeah. So we're getting the same error every time we run with the same seed. Okay. So we're just going to hit an assert, hopefully. Who knows? Maybe the debugger will make it different for some reason. The problem with tests is heavily multi-threaded, and because of the way it's architected, there's no way around that. And that's actually a problem that we need to address. But sometimes that doesn't matter, and in this case, it's not. Okay. So what is supposed to be going on here is a compound declaration is when you say like A comma B colon equals something, right? And we expand that, we make a syntactic expansion for that at type checking time, because what we do, depends on that. And then by the time we get here into sizing, we are supposed to have done type checking for all this. So sizing, this is in a struct somewhere. So let's go, let's find out where, if I spell it right. Uh-oh. I don't think we will have flushed this. I might have to, because it's in an assert. I don't think we're going to have this file. Let's see. Let's see if it makes sense. Nope. It's not flushed. I had a thing that where we could force a flush. I'm not sure if I want to get into that and, right added strings. There we go. So I can go back here and if this assert's going to go off, we just do this. That kind of bothers me because we got a different error. That's a weird, what? Why is this not working all of a sudden? I guess it's because it's heavily threaded and it's causing problems. But we are getting the right thing sometimes. Okay. So hopefully we did flush our added strings. Oh, I forgot to put a no check in there, but hopefully we'll remember that. Okay. Line 164 again. So, yeah, this is a compound declaration. We're generating a matrix kind of a thing. And so we're desugaring that. And that hasn't happened for some reason. This is a pretty straightforward struct. So the question is, why are we here? This thing's still in the infer pipe. And it doesn't have a type. So like, wait, this is legal. Okay, when I wrote this code, I was just confused. This is going to be easy to solve, I think. So this function is supposed to return false if we're not ready. And this might not be ready. Although maybe not. Let me see. So before we ever do here, so we get there here, right? We call collect statements in order. Yeah, and I guess we're just supposed to return false. Oh, wait. Okay. For some of these things, we don't have to do that, even though, and that's down to, I think, implementation decisions in the compiler. Or is it? Like, so a static if, it puts this thing called an inserter on the scope, and we're not supposed to get there until that fires. Compound declaration, I'm not sure if it does that, because it was written before inserters were a thing. And so maybe the right way to solve this. Yeah, see this thing waiting on inserters? If we're waiting on inserters, we're not even supposed to get here. And so what's an inserter right now? And is a compound declaration not an inserter? And if not, probably should be. Oh, let's put the no check in. Okay, static if's an inserter. Using's in, oh, compound declaration is supposed to be an inserter. So the question is, was it removed for some reason, or was it never put there? Do I have a flag, like a debug flag? Do I ever clear this? No. So I can assert on this back where we were having that problem, and we could see we're just going to assert compound and we'll see if that goes off. Once we get to the same error. are we getting here? Attempt to modify a procedure that's already entered the bytecode pipeline. Okay, here we go. Interesting. It does claim that it added an inserter. So maybe it added it on the wrong scope for some reason. Or maybe it was removed for some reason. Inserter scope. Oh wait, do I save that? Is that the target scope of the insertion? I need to look that up. But if so, that is not the right place. That is waiting on inserters. So why is inserter scope? That's a polymorph. This could be a copier problem, which is one of those reasons why I want to get rid of the copier. No, it doesn't have anything to say about inserter scope. This does seem to be a problem, though. It is incorrect. Well, I mean, certainly I can just break where we add inserter for this guy. And I assume that inserter scope just gets set when we call add statement, right? So like its enclosing scope is not set correctly. Probably. Really? Oh, it changed. Oh, God damn it. This is the problem with this test program is I can't run it reproducibly. We're going to try going by line number. I hate this test program for this reason. We're going to go by line number. And hope that that doesn't kick up other, it could kick up a lot of false breakpoint positives. Okay, no, I mean, it looks like it's in the right neighborhood, so we're gonna think this is the right one. 702, we'll see at the end if that's what we hit, if we even hit the right bug. So the enclosing scope is set to this. And so the question is, does the enclosing scope change later? Or what? Remove from scope. Okay, here's what's going on. That flag, that flag that I set, or that I looked at in order to tell that this had been inserted, was originally put in so that I could get around a problem where some things were inserting themselves twice. So I was like, I could try to sort this out, but right now I'm just going to let them set this flag, and then if they have this flag, they won't insert again. Well, if you have something in a scope, and then you remove it from a scope and put it in another scope, that flag is going to be set, and you'll be sorry that you put that flag into the source code in that case. Now, I'm not sure why we're doing remove from scope. Because it's the same scope. And this, okay, this probably removed the inserter. I guess not. Okay, so this, I definitely want to do this tomorrow when I'm fresh because it's going to involve wanting to go to great lengths to clean things up probably. So, remove from scope. Doesn't clear inserter and flag. That's problem number one. Problem number two is, why are we even doing this? And this might be related to why some things were inserting themselves twice, for all I know. Maybe not, because I vaguely remember that being something else, but... not set and closing scope. I mean, it is the same scope. Oh, and then we add an inserter here. Okay, but this, right, that's our data breakpoint, which we're again saying, oh, we set the scope. And then we're going to go here. This add inserter is not going to do anything. It's going to say, oh, this is set. So it's not going to do anything in that scope. Now, the thing is, it is already waiting on this guy. So this is ED98 is the last 4 digits. And ED98, it's right there. So it is waiting for this guy because his scope is already set, which is weird. But there's all these questions about who's supposed to be setting the enclosing scope for people. And I think it had to be set before because we used to do this desugaring earlier in the pipeline. Now we do it later, so it shouldn't have its enclosing scope set. Okay. We queue it. It's already queued, of course, because we already called add to scope. All right. So does that happen again, though? Yes. Oh, because all of this stuff, okay, so this compound declaration is desugaring into a parent declaration. And then that thing is going into a different place. Lawler coaster. When you say run and insert, that's what happens. So it's actually getting called 3 times, and the 3rd time is to a different scope, right? So even both of those first two times were kind of pointless. It was kind of pointless to add an inserter. So I want to see, so we have this flag block belongs to static if. And I think maybe we don't do an inserter in that case. Right? So we could make a flag of like belongs to run and insert or whatever. But it doesn't. Yeah. Totally different. So this thing is a special case for a static if inside another static if. I think I'm going to name this flag to something else and have everybody check it before adding inserter. Because, well, okay, first, I will make it well, I need to think about it. I mean, yeah. You don't want to end up in some kind of Google Chrome situation where you're doing all this unnecessarily flailing, like removing from scope, removing from the inserter list, adding to scope, adding to the inserter list, removing from scope, removing from the inserter list, right? And part of how you make your compiler fast is by making it not do those things. I also want to get rid of that flag, though. Yeah. And if I do this right now, you know, it's not that late at night, but this is one of those days, you know, I feel like when I drink way too much caffeine, it kind of takes me out for a day or two afterward. And I feel like that today. I've been kind of slow and pokey and tired today. And it's like, oh yeah, I did drink a ton of black tea yesterday. So I think that's where I'm at. So what's going on is just, I think a little bit of cleanup should happen involving these flags. I could start a teeny bit. I keep saying this is all I'm going to do. Let's just see. So we're not really, this was just some debugging help. We don't really have any modifications. Oh, well, there's that. So I could go to parser and I mean, this is not great. So we call add statement down here, and add statement does all this inserter stuff. But this is in the parser, and we don't really want to do all that stuff. So this is kind of a big cleanup where it has to happen for lots of reasons. I thought this add statement thing was really cool back when I did it, and we have to undo it. Fortunately, that is the only call to add statement in the parser, unless there's one in ast or somewhere. 10 p.m. smooth brain. Yeah. I'm tired and I'm yawning and all this. And I think it's just too much caffeine. And maybe also just too much sitting around the house, you know? Like, it's okay though. I don't actually need to fix this one to ship the beta. I think we ship the beta first, maybe tomorrow morning, and then fix this. Because this could be extended, and I think we document at least one thing in the morning, ship the beta, and then hammer on this. How do you know how to make a language plus compiler? Well, I used to do this for fun. What sort of bugs am I seeing coming back from beta users? Just stuff like we fixed today. Just like, oh, I did this weird thing and it gave me an error message when I think it shouldn't, or it crashed when I think it shouldn't. So, you know, nothing like... It hasn't been anything heinous. It hasn't been anything where it's like, oh my God, this puts the whole compiler in jeopardy. No, it's like, it's small things like that for the most part. And none of them have really been structurally difficult to solve, which is good, right? You can imagine getting a bug back and being like, oh my God, we have to rewrite the whole compiler internals to fix this. But fortunately, I hit all of those. Well, not all of them probably, but I hit a lot of those myself like 2 or 3 years ago and already did all that work, right? So it's at least robust to a certain degree. Do I know if any of the testers are working on bigger projects? I mean, it depends on what you call a bigger project. Some of them have definitely talked about what they're doing, and you know, it's not like Hello World. The people are definitely doing more sophisticated things. What is the ratio of bugs to feature requests? I don't see that many feature requests, and I think it's in part because, well, I don't actually want that many feature requests right now because the features aren't done. I want to burn through the feature roadmap, but also like, people don't really know what all the features are because it's not that well documented, right? So like, they don't really know what's there. And even if you have some map of what's there, you know, it's a big programming language. So when you start using it, you know the basics, right? And then you maybe pick up more as you use it more. So I think once people use it for a long time, they would have, well, and also, you know, if you start using a programming language and you're like, oh, I wish it did blah, 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 you might just wish that because that's how you program in a different language, right? And anytime you go from one language to another, if you don't do things naturally the way that that language wants, then they're going to seem a little bit, you have to change your style a little bit, right? When you use a different thing. And so, you know, as people use it more, they'll accommodate more in that way, and then we'll have opinions based on experience, right? And so, yeah, that is what it is. Is my Windows system clock ahead by 3 minutes? Yeah, approximately. Do I intend on commercializing? What does commercializing mean? That's good though, because this compound declaration problem is one of the big problems that the build server is having all the time. And so once that is fixed, that'll be great. Any evidence that users are getting the productivity gains posited? You can't. Those things are hard to measure. Like, I don't think that I would ever like attempt to do a study where you measure, because it's impossible to measure, because I mean, you would have to implement the same thing in both languages, but you would be more experienced at it when you did the second one, right? So you'd have to do a bunch of things and swap the order. I don't know. People tell me they like programming in it. And I like programming in it. And I feel fast when I program in it. But yeah. Will it eventually be a closed source? It's a closed source project right now. But no, it'll be freely available to people. You can't, I don't think a programming language that you make people pay to try is a good way to get people to use your programming language. Yeah. Yeah, like if somebody wants to write serious software and they're like, I want to make sure that I can maintain this software for 20 years, they're going to be like, oh, and you want me to use your closed source compiler that you'll never give me the source for? What if there's a problem that I can't fix? RIP, right? And so, yeah, you don't want that. You want, if you're serious about making a project, you need to, in the limit, be able to look at the source of your compiler to understand how it works. You need to be able to patch problems in it. You need to be able to change things that might not be the way that you like. So that will happen eventually. We will give out the source code, but not for a while yet. Windows 2025 comes out, that totally breaks everything. Yeah, exactly. Yeah. And like, even if you said like, oh, don't worry, we're going to support this and make sure it works in the future, how do they know your company's not going to go out of business, right? Like, if you're a really large, stable entity like IBM or the US government, you can do that kind of thing. But like a small company, you can't believe that they're going to still be in business to support their proprietary programming language. No, we might still change the syntax. I don't know why people find that implausible. Yes, absolutely, we may change the syntax. How do I know my company won't get bought by Oracle? Because I probably won't sell it to Oracle. What are my thoughts on Python's way of using white space to structure code? I don't like it. I don't like it. So we do not have the plus plus operator in this programming language, and so I don't think there's a danger of somebody making a plus plus version of it. Oh, right. That's a good point, actually. I didn't think of that. Obviously, they just add the plus plus operator, and there you go. I mean, if you're adding stuff to the programming language, you got to add the plus plus operator. All right, I'm going to go to bed. Thank you, everybody, for coming by, and I'll see you later on. Bye.